good evening, everyone. My name is Andrew Zignani, Senior Research Director for ABI Research's Strategic Technologies team. As part of this role, I've been covering the wireless connectivity market for the last 11 years, providing qualitative and quantitative research on technologies such as Wi-Fi, Bluetooth, 82.15.4, ultra-wideband, and of course, Wi-Fi HaLow. And today I'd like to welcome you and thank you all for joining this Rethink Wi-Fi with Wi-Fi HaLow webinar. I'm very excited to be able to share with you some of our thoughts and perspectives on this innovative technology. And I hope you'll all find this a very interesting and valuable discussion as well. And of course, I'm also delighted to be joined today by Michael Daniil, CEO of Morse Micro, one of the leading providers of Wi-Fi HaLow technology. And while it is 10 p.m. Here on April 8th in the UK, where I am, Michael joins us from the future on April the 9th, which is actually World IoT Day. And I can't really think of any better time or a better person really to discuss the future of connected devices and how Wi-Fi HaLow is set to transform the IoT market. So Michael, I don't know if you want to just quickly give a quick introduction to yourself.
Yeah, fantastic. Thank you so much for organizing this session, Andrew, and I appreciate you staying up late to join us on World IoT Day, such that we can host this as well for our friends in the United States during daytime. So my background, so I'm a Wi-Fi chip designer by origin. I founded Morse almost 9 years ago now. And so at Morse, we're reinventing Wi-Fi for the IoT markets. With the focus on the new Wi-Fi HaLow standards.
Yeah, fantastic. Thanks, Mark. And I'm really looking forward to our conversation today. But before we get stuck in, I just want to do a bit of housekeeping first of all. So just to run through what we're going to be doing in the next half hour or so. So firstly, for those who may not be that familiar with Wi-Fi HaLow technology, we'll provide an overview of the technology and then highlight some of the major application segments that Wi-Fi HaLow is currently addressing and will be able to address in the future. And secondly, we'll provide some insight into why now is the right time for Wi-Fi HaLow to really help transform some IoT applications, highlighting the growing momentum for the technology, the continued technology innovation, real-world products that are already arriving on the market today as well. And alongside this, we'll also highlight how developers, can take advantage of these solutions today and other resources as well from Morse Micro that are available. And then finally, at the end, there'll be some time for some Q&A. So I'd encourage you, if you have any questions, just to save them for the end of the session and we can address them then. So yeah, looking good to start. And one final thing, obviously, before I like to mention before we get fully underway is that ABI Research and Morse Micro recently published a white paper on how Wi-Fi HaLow is poised to transform the IoT market. And if you see the QR code on the top right-hand side, or visit the Morse Micro link below, you'll be able to download this for free. And this paper just provides a more extensive discussion of how Wi-Fi HaLow technology can address various different connectivity challenges across the IoT verticals, as well as highlighting some real-world trials and case studies of the technology, and providing recommendations on how to build a strong HaLow ecosystem.
I just wanted to
yeah, go ahead.
Thank you on that white paper as well, Andrew. I think it's so we've got it on our website. It's one of the most viewed pages on the website. I think Maggie just told me we had over 500,000 views on the this one.
That's a lot.
It's it's really good to have like an analytical view of like what Wi-Fi HaLow is and what it's not, right? So it's great to have this third party.
No, it's a pleasure. It's a pleasure, absolutely. And obviously, you can read more about the technology in the paper, but I think, Michael, perhaps first it would be good to provide a brief overview of what Wi-Fi HaLow technology is, of course, for people who may be unaware, how it may set itself apart from other IoT technologies, and also, of course, the role of Morse Micro as a leading provider of Wi-Fi HaLow solutions.
Yeah, absolutely. So maybe first I'll start by saying like Wi-Fi's been around for I think it's 25 years now. Some of you might know, but like it kind of like originally was kind of co-invented here in Australia, in Sydney in the late 90s, where they kind of came up with the idea of like using OFDM for wireless transmission, which turned into the 802.11 standards. And so what we've seen over the last 25 years is really an explosion of Wi-Fi, right? Like it's gone from a dongle you can plug into your laptop, or like a PCMCIe which you can plug into your laptop, to something that's embedded in everything today. And over the last 25 years, we've seen Wi-Fi just evolve so much. Rather than it just commoditizing, we've seen it really expand and grow faster. It's gone up in frequencies. So we've seen it expanding from 2.4 gig to 5 gig to 6 gig. Even it has some 6 gigahertz work. And one of the key advantages of doing that is that you can really increase the bandwidth. So we've gone from tens of megabits per second to literally tens of gigabits per second in Wi-Fi. With Wi-Fi HaLow, we kind of gone the other way around. We said, hey, like who needs like gigabits per second for IoT devices? What we focus on is really reliability. It's like when it must connect, when you want to have that reliability, then instead of giving you gigabits per second connectivity, let's give you megabits to tens of megabits of connectivity, but at extended ranges using lower frequencies. So it's basically, instead of going up in frequencies, we've gone down in frequency. So we've gone to a 900 megahertz band in the US, it's 880 in Europe. And the main benefit there is you get much longer range and you get much better penetration through materials. So it just increases the reliability a lot.
Yeah, absolutely. I think one of the best ways to think about also, Wi-Fi HaLow in particular is also that it is an extension of Wi-Fi technology as well, into the sub-gigahertz band, and you can really enable some unique use cases that provide, whole home or whole building coverage, whole neighborhood, level coverage as well. Lots of benefits on top of that, offloading from congested frequency bands, 2.4 gigahertz in Wi-Fi, very congested over the years. You can easily integrate that technology into access points as well, which is becoming increasingly important going forward. And of course, being a Wi-Fi technology, it takes advantage of the inherent, interoperability and certification program from the Wi-Fi Alliance as well. So I think it really, as you can see from this slide, it really offers a unique set of features compared to the competition. Again, you mentioned the key aspects around signal penetration, robustness, but also the scalability and being able to support, thousands of devices from a single access point is really important as well. And I think, its role as part of the Wi-Fi ecosystem will really help drive, the future of the HaLow ecosystem going forward as well.
Yeah. Yeah, and I think one of the key things as well, it is a standard, right? It's an IEEE standard. Yep. It's IEEE 802.11h. There's the Wi-Fi Alliance, a body around it. So we do interoperability with multiple vendors. And so it's not just like a proprietary standard that companies have to bet on. Like this is a standard. There's multiple vendors that keep each other honest. And it's here to stay. So you do have that certification program from Wi-Fi Alliance. There is also that, like once you get a product certified, you have that kind of sticker that basically gives you that certainty as well on security and on interoperability. So I think that's one of the key things as well of Wi-Fi HaLow versus some of the other kind of proprietary IoT solutions.
No, absolutely, absolutely. So I guess, moving on with all these advantages we discussed in mind, really, perhaps it'd be good to discuss, some of the key application sectors where, Wi-Fi HaLow technology has the most compelling advantages. And as someone who's seeing this demand, firsthand, what are some of the key applications that Morse Micro is seeing and currently engaging with? And of course, tell us more about the kangaroos if you can as well.
Absolutely. So one of the things with IoT is like it's so broad, right? Like there's so many different use cases. So I'll just maybe touch on a few that we see customers like implement technology very successfully at. The first one is kind of home security cameras, and so this is like, I should maybe be more clear. So this is outdoor cameras. So this is not the cameras you have inside of your home. This is cameras that you can put outside of your home. Today, with 2.4 gigahertz Wi-Fi, you're kind of limited to the walls of your building. You can have cameras inside of your house. You can have like a doorbell. You can maybe put like a camera on the outside of a wall somewhere, and it's going to connect 90% of the time. But with Wi-Fi, because you have that 10 times longer range, which means you cover 100 times the area, you can cover an entire property. You need to live in a really big house not to be able to have full property coverage. And so we're seeing a lot of demand there in kind of home security, outdoor home security, for if people want to put a camera at the front gate, the back fence, the pool. This is the only technology that can do it. There's no other technology except for cellular maybe that enables you to have cameras far away from your home access points. And maybe just to dive into the video on the right there, the kangaroo. So So we're an Australian company. We do actually a lot of like field testing. And this is we put this on YouTube a year ago or so. This was captured by some of our field testing cameras in a rural property in South Australia, where we've got actually we built like a mesh Wi-Fi HaLow system, and then with cameras spread out across the property. And it's amazing what you start capturing when you can put cameras at anywhere you want. Right? So this, I think, was a camera a few kilometers away from the main residence. And so if you go on YouTube and look for it, look Morse Micro kangaroos, you'll find this one.
Yeah, it's a really great demonstration. I think not just the distance, but also the throughput that's achieved as well, and the quality you can see from that is really impressive over such distances. Absolutely, and I think it's also important to mention, Michael, that these are not just testing. These are real world products, that are now on the market leveraging Wi-Fi HaLow technology, and includes, as you said, a range of security cameras, smart doorbells, there's people and sensing cameras on the market. These roaming agricultural hotspots for kind of smart agriculture applications as well, as you can see on this slide as well. And I think, as you said, one of the challenges for Wi-Fi HaLow is that there are so many different potential applications and different connected devices, market verticals that can benefit from its unique characteristics of long range and low power consumption as well. So if you just take the smart home as one example, you're looking at not just video related applications, but potentially connected extended range devices like consumer robotics, wireless sensor applications. Also access control potentially for outbuildings, garage doors, other access to the property as well. As we see increased demand for EV charging infrastructure as well, you need an extended range connectivity to the home, and also smart utility companies can leverage this for neighborhood area networks as well. So the possibilities are enormous with Wi-Fi HaLow in these environments, and that's just one vertical, of course.
Yeah, exactly. And this is the challenge that we have today with a kind of Wi-Fi 4, 5, 6, 6E, 7, 8 in the future, is that if you're an EV charger or if you're like an electricity meter, you don't need that gigabits per second connectivity. You just need robust, reliable connectivity. And so it's one of the challenges, for example, with smart metering, with electricity meters. If you want to connect your electricity meter to the home network, it's a challenging problem to do with 2.4 gigahertz Wi-Fi, because your meter might be in the basement, it might be outside, and it just doesn't work reliable. And so that's what we're solving. And so for example, smart metering is one of the use cases that excites me the most, because it's like we're now really enabling us people to connect like your electricity meter and the grid to your home Wi-Fi, giving you that. And so there's a few reasons to do that, right? So the first one is just that you can get that instant visibility, like knowing exactly how much energy are you consuming right now, and being able to control that as well, like figuring out when does it make sense to charge my car? If you have solar panels, like when do you use them? If you have like electric water heaters, like how to control all of that. So there's the kind of the prosumers who love that, but also there's a lot of value for the grid operators to balance the network and do that. And then another use case, for example, with that is like you have like in Sydney, for example, most people live in an apartment. You have hundreds of apartments in a building. If you want to connect those meters to the internet today, the only way to do that is use cellular connectivity.
Yeah,
it's incredibly expensive. It allows you to do only a few megabytes of data per year, and it's not always that reliable, right? Like if you've got a meter like in the basement, like it's just not going to connect to your cellular network. And so with this, you can actually aggregate all these meters together and have like one robust, reliable uplink into the sky. And then third of it is just more these behind the meter solutions where you want to connect your meter to your solar panels, EV chargers, your appliances that use a lot of electricity, and be able to control that load.
Absolutely, I think this is obviously only just one single market vertical we're talking about here, but obviously the unique characteristics of Wi-Fi HaLow can deliver new experiences across multiple different verticals, and I want to touch on the next slide, because I think a really compelling example of the diversity, I think, of Wi-Fi HaLow's potential applications across both consumer and enterprise was recently very well highlighted in the wireless broadband alliance trials in a recent report from them last year. The WBA published a report which you can download if you select scan this QR code in the top right hand corner, where they really demonstrated, I think, and proved the benefits in terms of range, in terms of signal penetration, battery life, scalability and other benefits of Wi-Fi HaLow across not just the smart home, but also industrial market applications, warehouse and logistics operations, connected farms, smart agriculture, as well as smart city and smart building applications. So, Michael, I know that Morse Micro were very heavily involved, of course, in these trials. So, is there anything you'd like to just highlight that really stood out to you about the experience and what Wi-Fi HaLow was enabled to deliver in real terms as well?
Yeah, so I think the key advantage of Wi-Fi HaLow in those, like let's say this warehouse trial, for example, is you can have a single access point cover an entire building. Not just the inside of the building, but also the outside of the building, right? So now you can start connecting things that move around, like those smart robotics or people holding scanners or those devices that are used to print labels, move things around, can now just connect to a network that's reliable, robust. And if you compare this with Wi-Fi 6, for example, right? Like if you can get out of, and it happens, right? So every warehouse get it out with like tens to even hundreds of Wi-Fi 6 access points to give you kind of this gigabits per second connectivity everywhere. But especially for stuff that moves around, like you have to keep roaming from one access point to another access point to another access point. And it's a non-trivial problem, right? Like even at our office here, like we sometimes struggle, like when we move with our kind of MacBooks from one side of the building to the other side of the building and that's Apple like struggling to get that Wi-Fi roaming working. So imagine all of those IoT devices in a warehouse, they struggle to connect to your 2.4 and 5 gigahertz network, especially if devices move around, if stuff moves around in the warehouse. And so it's fantastic now to see this being adopted into things like Android scanners, tablets, but also in things like AI sensing cameras, right? So it's those kind of systems you put around a building that can analyze how full a warehouse is, like what the stock levels are, that can alert you if there are certain things happening. And so we're seeing an explosion as well in that market segment where it's not just having a camera stream going live into the cloud all the time, but it's having that local AI inferencing and really analyzing what is happening and giving you the relevant data.
Absolutely. I think before we move on, to the next part, I think, there's one specific trial, I think, in terms of the smart building application, which I've highlighted on this slide, where you just have just 4, Wi-Fi HaLow access points covering a whole smart building, to enable, some valuable building automation services across multiple different floors. And I think this really shows the huge benefits of Wi-Fi HaLow in reducing the total cost of deployment. I think that's another key factor. Due to the reduced installation costs, you have reduced deployment complexity. You don't need as much additional hardware to enable those different applications as well, and also the kind of simplified integration with the existing wireless networks as well, being native IP and obviously a part of Wi-Fi technology as well. It really highlights how Wi-Fi HaLow can enable so many valuable new smart building services over an IP-based network as well. So I think that's a really compelling example of why HaLow is so suited to these larger scale enterprises.
Yeah, maybe one more thing that kind of really excited me in this white paper was the work we've done together with everyone associated in kind of testing Wi-Fi connectivity in school campuses. And so one of the really amazing things is like single AP now can cover an entire school campus, and this is not to connect the laptops of your school kids. This is more to connect things like access control systems, like the door locks, the security systems. And we have several customers now in building kind of like door locks for schools such that they can be controlled wirelessly. And it creates that incredible, reliable network. And so it's used for things like opening, closing doors, lockdowns. It's used for now embedding cameras in locks and really making things much smarter and much safer.
Yeah, absolutely. And I really would encourage anyone who's watching to scan that QR code and really download and have a look at, some of the real compelling benefits, because it really does apply well to multiple different applications. Now, obviously, there may be some in the audience who are familiar with Wi-Fi HaLow technology and know that it's been around for some time now. And they may be asking, why is now the time in which Wi-Fi HaLow is poised to transform, the IoT market? So, Michael, from yours and Morse Micro side, how has Wi-Fi HaLow developed over the last few years to really make it a mainstream success that it can be capable of?
Yeah, that's a great question. So the standard was published in 2017. We started a company just before that. And then it takes a little bit of time, to be honest, like to to build a Wi-Fi chip company. We've got 200 engineers in the company now building this product. And so we launched the first chip 2 years ago, which got adopted by several of the module vendors. We also now been working together with our competitors through the Wi-Fi Alliance, as well as with multiple players in the ecosystem, right? So in a way, we're creating a new market. You need this chip, or you need Wi-Fi HaLow both on the access point as well as on the station. So it does take a little bit of time, and so we're growing this market, and we're very pleased now to have several partners for this first generation part. Just this year, we announced our second generation part, which is the one on the top right here, which is the MM8108. The key thing with this one is we've done much more integration on this. So you're looking at a much kind of smaller part with much more integration. So this one now has a kind of integrated PA that gives you a 26 dBm output power. So that's kind of 400 milliwatts output power. And it does it at extreme power efficiency. So we're sitting there at 37% efficiency. So which is, to put that in context, it's about 4 times better than any other Wi-Fi chip on the market today. And so where this is important is when you put this in like a battery powered outdoor camera, your battery is going to last 4 times longer than any other camera, on top of the 10 times the range you get with this with Wi-Fi HaLow. So that's really good. The other thing that we've done on that one is we've added a USB interface, which makes it far easier to integrate this into existing devices that have a USB port.
Yep.
So think of like access points with a USB-A port. Now you can have a little dongle you can slot in, and you have a Wi-Fi HaLow access point. Same with any devices that have a USB-C port. They're like like if you have like Linux-based industrial laptops, even like if you have like any machine with a USB-C port, like a POS terminal, you can plug in a dongle, and now you have like multi-kilometer Wi-Fi. So that's been really exciting, and I think that's really now what's going to propel the market forward. Is that it makes it far easier to adopt this technology. You no longer need to buy like an access point and a station. You can now have like a station that goes with a little dongle. And so what we'll see over time is, so step one will be the same as with normal Wi-Fi. Step one is like, okay, we'll start seeing kind of dongle deployments. Step two will be the integration of Wi-Fi HaLow into all of the access points.
Yeah, absolutely. I think those are all extremely, important points in building the ecosystem. I think as someone also covering the wireless connectivity market on a daily basis and attended recent events, such as CES, MWC, Embedded World, you can clearly see the development, not just from a technology perspective, but more importantly, I think from the ecosystem side. So we're seeing a lot of momentum, industry momentum, not just from yourselves, but also the wider industry momentum for Wi-Fi HaLow technology. And again, we touched upon things like the certification program a few years back, bolstering interoperability. But now you have a much wider availability of chipsets. You have a whole bunch of module partners here listed in this side of things as well to help speed up development. You have regional incentives promoting, different regulatory incentives for Wi-Fi HaLow technology across different regions to promote the technology there. So it's really, becoming, you can see the ecosystem growing in real time. And I think the interest as well, and the growing interest, we're certainly seeing that from a research firm perspective. And I think as well, there's still a lot of IoT challenges that need to be solved. I think there's not a case where, all the problems have been solved suddenly and everything's good to go. I think, there's room for technologies like Wi-Fi HaLow that have a unique kind of value proposition. And I think if you look at alternative competition from the likes of LPWA technologies, these are often limited in terms of bandwidth and congestion as well. So Wi-Fi can really provide some benefits to, through its additional throughput, but also, offering this bi-directional communication without limiting the capacity of the network. I think is really important for many different applications. Not having a bottleneck on the overall network capacity is really important to, enable things like firmware upgrades and, support larger capacity networks going forward. And I think it's also important to remember that it's an unlicensed technology as well, so there's no additional fees that you have to pay on data and traffic and everything else, which if you're looking at deployments of thousands of nodes on a single site, that soon adds up, right? And I think that's another compelling value proposition is the reduced total cost of ownership, I think, for Wi-Fi HaLow technology.
Yeah.
And then if you look at the kind of opportunities we talked about, you're talking about, a total market perspective. There's 88 billion connected devices forecast to be on the market by 2028. So even if Wi-Fi HaLow it captures a small portion of that market, then you can see that there's some significant opportunities for that technology. And we know that traditional Wi-Fi, is already significant in the IoT space, but I think having additional flexibility of Wi-Fi HaLow will be really important going forward, and also enabling new use cases for Wi-Fi technology as well. So that's why, as you can see on the right, we forecast Wi-Fi HaLow to be one of the fastest growing wireless technologies in the coming years, achieving a 56% CAGR between 24 and 29. So, we see this growing interest. I'm sure you're seeing this growing interest as well on your side.
Yeah, absolutely. And I think it's great as well to see this. It's not just us pushing this, right? So IEEE, they're the ones that kind of invented the standard back in 2017, or 2017 was published, but it's been in the making for many years, right? It was kind of Qualcomm put a lot of effort in this. Then after IEEE certified the standard, now it's Wi-Fi Alliance working on interoperability, and so that there's hundreds of member companies involved in that. It's great now to see kind of the wireless broadband alliance as well adopting this, doing all these field trials across the US. And then for example, it's listed here as well, the HPC. That's the it's kind of the 802.11ah Promotion Council in Japan. So this is a body in Japan with I think it's over 200 member organizations that meet every month to talk about the Wi-Fi HaLow use cases, how they're going to deploy it. And they're also opening up additional spectrum now in Japan for this. So it's great to see literally thousands of people around the world really pushing this standard forwards. And maybe just to touch on one other thing, Andrew. So you mentioned different LPWAN technologies. I think one of the key things of Wi-Fi HaLow is this is an extended range LAN technology, and it don't really compete with those kind of WAN technologies. So I think there's been many WAN or LPWAN technologies out there that give you long range, ultra low throughputs. This is more a LAN-based solution that gives you up to 43 megabits per second throughputs. And when I say LAN, we've done testing. I think there's on the bottom right here, this kind of video from in San Francisco on a beach. We did testing where we showed a 3 kilometer range video call. We repeated that test actually in Joshua Tree National Park, where we tested up to I think it was 9.9 miles range, which is 16 kilometer range video connectivity. And so even though it's extended range LAN, you get many kilometers, up to 16 kilometer range with this. But you get 16 kilometers if you're in the middle of the desert. You're not going to get that if you're in the middle of San Francisco.
Of course, yeah. You don't do so much, right? Yeah.
But the focus really is, okay, if you have a LAN-based application and you care about robust, reliable connectivity, then this is the right solution.
Absolutely. It's still an extension of the kind of Wi-Fi technology, right? And I think that's the important thing to remember, but also, can really enable some of those kind of extended range applications that transcends different market opportunities.
Exactly. I think that's it. It is just Wi-Fi operating at a lower frequency, giving you that additional range, range and reliability. But the key benefit is it is just Wi-Fi. It's based on 25 years of legacy. You get WPA3 security, you get certifications, multiple vendors, and also it's just it's that TCP/IP connectivity, right? So if you connect the device over Wi-Fi HaLow, it's just like any other Wi-Fi device. It plugs into your Linux system, you load the drivers, you're done. You plug it into an OpenWRT access point, you load the drivers, and now you have a Wi-Fi HaLow access point. And so with many of the LPWAN technologies or WAN technologies, you have to start building everything on top of the PHY or MAC layer. Whereas in this case, it's all done. You have WPA3 security, you have TCP/IP connectivity. It plugs straight into AWS or Azure or whatever cloud system you use. And you can connect 8,000 devices on a single access point. So it's far easier to deploy than trying to build your own, let's say, mesh Bluetooth system or Zigbee or LoRa or Sigfox or any of the other kind of more proprietary solutions that are out there.
I think that makes a lot of sense, right? There's always a benefit to kind of having a single hot technology, one that's native IP, one that you can easily integrate into your existing infrastructure and also manage effectively as well, right? So it's not just a case of the installation side of things, but also how do you manage that network over time? How do you integrate it with different services that you already have? I think having that part of the Wi-Fi network, which many enterprises, of course, have already, makes it so much seamless and reduces the overall complexity and burden on enterprises as well, which is really important.
Yeah, exactly. And I think the fact that you can do this without needing mesh is it's a great benefit. And this is, for example, we're seeing a lot in the access control system. Most people in access control today, they use either kind of a Bluetooth or a Zigbee mesh solution to make things work, right? And so if you go to a hotel today, you'll see like those kind of Zigbee or Bluetooth access points every 10 doors, and they use that to connect the doors to the network. And it's not always that reliable, right? And so the benefit here is like single AP can cover like an entire school, an entire hotel, and give you that reliable connectivity. So when you say the door has to open, it will open. When you say the doors have to like lock now, they will lock now. And we do this at a similar power budget than these other technologies. Having said that, you don't need mesh because it's just Wi-Fi. It also supports mesh, right? So it supports
of course. So you can have that extended range network.
Yeah, exactly. But you don't need it for 99% of use cases.
Absolutely. But still, you can do it if you want to.
Exactly.
So yeah, obviously, we've talked about the benefits and use cases and opportunities for Wi-Fi HaLow technology, but how can developers and others attending this webinar, actually take advantage of Wi-Fi, technology, Wi-Fi HaLow technology today as well?
Yeah, that's a good question. So we have a range of different eval kits. I'll be honest. So most people that want to start with Wi-Fi HaLow, the first thing you want to see is you want to see how far does it actually go. In my use case, like if you go to a warehouse, you want to see, does it actually cover my warehouse? Does it cover my school? Does it cover my supermarket? And so step one is you want to test that range. Then typically the second step people do is they want to see, okay, at that range, what speed do I get? And does this speed kind of match with what I need? And then people start looking at reliability. Okay, like how reliable is this for other technologies? And so I'd say like for these first 3 steps, like we typically recommend this kind of HaLow Link 1 product, which is the bottom left. It's a very simple Wi-Fi 4 plus Wi-Fi HaLow access point. And so you can get this on Mouser for $99. And it's an out-of-the-box experience. You can give this to your grandma. She'll be able to set it up, and she'll be able to test out how far does this go at her property.
Yeah.
Once you're convinced about the range, speed, and reliability, then often for battery-powered applications, people want to start looking at power consumption. For that, we have this EKH05 eval kit, which is at the top left. So this is a platform that has an STM32 and a Wi-Fi HaLow module from Morse Micro. And it allows you to hook up any kind of sensor you'd like. So there's a camera sensor here, there's I2C, SPI, UARTs, you name it. And it also allows you to measure the currents of all the different components in this platform. And so if you're building like a battery-powered IoT solution, then you really care about that power consumption. And now not just the peak transmit power consumption, but also like that sleep current. And so I'd say like in 95% of applications where Wi-Fi gets integrated are all battery-powered applications. And so you're down at the tens of microamps range for use cases that are responsive to the network. So I'd recommend for those devices to use that EKH05 platform. And then once it comes to integration, then we have a range of different module partners. We have like Quecteleger, Wave, HDF, ACSIP. We all have like little modules that you can then integrate into your devices. And then at the bottom right here as well, we've got our new kind of 8108 USB dongle. So this is the chip that we announced at CES. At this stage, we're sampling this to our kind of early access partners and tier 1 customers. But we'll be launching this to the broader market second half of this year. So this will become available on Mouser for anyone to try. And you can plug this then into Linux-based machines, OpenWRT-based access points, or you can then do driver porting to make it work on your application. And so we've got both a USB-A version with an external antenna, which is primarily for access points, as well as a USB-C version that has like an integrated antenna on it, so even much smaller. That's mostly for devices with USB-C ports like Android, tablets, phones, laptops, and so forth. And so yeah, like we actually have this working now, like a system with basically where you can plug this into a Google Pixel phone, and now you have like multi-kilometer Wi-Fi.
Yeah,
your Google Pixel.
just like that. Yeah. No, it's extremely impressive. I think, as the technology maturity occurs, and as you said, we've been covering the market for some time, and we're seeing the rapid expansion of module partners, which is so important to reducing the time to market for these solutions as well. So we expect many will take advantage of those, in the years to come as well, of course. And finally, did you also want to mention the kind of other resources that perhaps can help the developer community take advantage of Wi-Fi HaLow technology beyond purely on the hardware side as well?
Yeah, absolutely. So as we're kind of creating a new market, right? Like we kind of working with a broad ecosystem, and so one of the things we're really embracing now is the open source community. So just in December we launched our kind of open source community. We launched like a open source forum, and so we're really now opening up Wi-Fi HaLow to the broader community. I think one of the challenges as like when you're creating a new market is like you need to go focus on some of those really big opportunities, the ones like where we can sell tens of millions of chips into certain markets. But at the same time, we want to really now open it up to anyone who wants to use this technology, right? And so to do that now, we've open sourced a bunch of our software. We now have a community forum where we're getting overloaded with questions, and we're quickly hiring more people to answer those questions. But it's also great to see actually like members of the community answering questions of other members of the community, and it's really exciting to see that. And we're starting to see a lot of like contributions now on GitHub, on the open source repos, people porting our software to other MCUs, to other versions of real-time operating systems, and so it's really exciting to see that. So it's really now creating that ecosystem, making sure we get those 802.11h drivers upstreamed into into just main Linux operating systems, main OpenWRT drivers, and so forth.
Yeah, absolutely. I think it's a common theme of all the trade shows I've attended this year. Is basically how do you speed up that development time? How do you, enable the swifter tools to allow a much quicker products time to market, reducing the complexity, reducing the burden, and again, given the diversity of Wi-Fi HaLow's use cases, I think sharing that knowledge is becoming increasingly important to help different vendors scale up their solutions and really accelerate their own time to market as well.
Yeah. Yeah, actually, so one thing we did in February as well is we hosted a session at the WLPC Phoenix, so that's the Wireless LAN Professionals Conference, and it's actually been great to see like all the different use cases that audience has come up with of how to use Wi-Fi HaLow in different environments and use cases, and so we've been supporting that as well. Like we've been supplying some of those like HaLow Link 1 units and really trying to enable that community to get going with Wi-Fi HaLow.
Absolutely. So, well, firstly, thank you, Michael. I really appreciate you sharing your insight today, and I really hope the audience in attendance have enjoyed the discussion. Now I'd like to really kind of turn it over to the audience Q&A. So, if anyone watching does have any questions for Michael or myself, now's the time to send them through. I think some have already come through during the chat as well, during the conversation. Let's have a look and see what we can find here. Just trying to open up the chat as well. Okay, so one question asks, I've heard obviously Michael reference cellular technology as a well-known connectivity option a number of times, in specific times. Why would someone choose Wi-Fi HaLow instead of the cellular technology, basically?
Yeah. So that's a good question, right? So when we get this question often, like with cellular connectivity, you basically have internet anywhere you go, and it just works, which is true. Like I think cellular is fantastic for use cases that need to be ultra mobile, and where cost is not a concern, and where power consumption is not really a concern. So we recommend cellular for those kind of solutions, right? Like if if you have a high value use case where power is not an issue and you you don't really care about the cost, then cellular is great. The way to look at Wi-Fi HaLow, it is just that LAN-based solution, right? This is connecting your device to your access point. If you're in a warehouse, you could connect your thousands of scanners over to cellular, and you're going to be paying tens of dollars per month or dollars per month to Verizon for every device that you connect, and you're going to have to charge all of these devices daily. Whereas with Wi-Fi HaLow, you can connect them all to a local access point. You're going to be looking at modules that are much smaller, hence also cheaper, that will be consuming like a fraction of the power consumption, and that can connect robustly to a local access point. So you don't rely on a cell tower that might be miles away. And if the network goes down, you go down, you can just operate on your own Wi-Fi network. And so in a way, Wi-Fi HaLow really, it's a value add technology, right? Like it doesn't compete with cellular. It doesn't compete with Wi-Fi 4, 5, 6, with LPWAN. It's technology on its own that's valuable and has its own kind of space.
Yeah, I definitely agree with you. I think, you know, it has a very unique sweet spot and value proposition where it can do things that other technologies simply can't do. I think having the unique combination and scalability, both in terms of throughput, but also device density and everything else on top of that, makes it, you know, really compelling and really unique, right? I think, and that's where we see, you know, some of those kind of new IoT applications that are emerging today, where Wi-Fi may be a good fit to a certain extent, but it can't quite do enough, or we need to extend the range of the Wi-Fi network. And that's where I think Wi-Fi HaLow has a really unique advantage. And I think that's why we're seeing a lot of traction and interest in that, both from the vendors across the ecosystem that support existing Wi-Fi, they support cellular technologies. Now we see a lot of module vendors adding Wi-Fi HaLow to their portfolio as well. So I think to really help solve the other gaps, you know, that are in the market as well, that Wi-Fi HaLow can really play a significant part in as well. And just one final question for you, Michael, is kind of what's exciting you now in terms of the kind of future development of Wi-Fi HaLow? What are you most excited about, you know, going forward for Morse Micro over the course of the year? How are you positioning yourself this year for the growth of the Wi-Fi HaLow market?
So what really excites me is like that explosion of different use cases, right? We're seeing like so many different use cases now in access points, in AI cameras. We're even seeing kind of like use cases beyond IoT. I think one of the things that's like we've been putting quite a bit of work on recently, for example, is using, for example, Wi-Fi HaLow for kind of peer-to-peer connectivity. It's not for connecting a device to the internet, but be able to connect devices to each other. So actually, I've got one. Like, so that's, for example, that USB-C dongle. So this one now you can plug this into an Android device, and now you can have multi-kilometer range from the Android device to like an access point, but also between devices. So you can, like, if you're on a rural farm in Australia without cellular reception, you can now communicate, right? You can have internet connection back to your farmhouse when you're like 16 kilometers away. But also you can communicate with your friend who might be miles away and just have that kind of peer-to-peer connectivity through this technology. So I think there's really an explosion of different use cases, and it's going to be so exciting to see all the new kind of products that it's going to be able to create.
Absolutely. I think we have another question, actually, maybe more region specific. So what's your vision of the growing applications of the technology in Australia itself? I'm curious to hear more about that, actually. Not beyond kangaroos, perhaps.
Yeah. So Australia is like a massive country. It's same size as the US or Europe, right? And so there's limited kind of like cellular coverage, and this technology really allows you to expand your Wi-Fi connectivity. So for example, Starlink is incredibly popular here for rural Australia, and now people get like a Starlink connection down to their farmhouse, and now you get like Wi-Fi inside of the house. With this now, you can have Wi-Fi across the property, especially now if you apply mesh to that, you can cover like massive properties, right? Like, and you can connect not just the people there, but also those things like cameras, AI devices, sensors. And that really excites me. Like, it's something that you weren't able to do before. Now you can, you can connect so many more things to the internet than what was imaginable with legacy Wi-Fi.
Yeah, absolutely. There are actually some questions, I'm putting more technical questions. Maybe I don't know if we want to address them, but I can ask you them as well.
Yeah, no, happy to go deep in the technical domain.
Yeah, sounds good. So one of the questions was on in terms of the roaming times between APs. Any information on that would help, perhaps?
Yeah, so to be honest, I don't know the exact times for roaming, but it's just like normal Wi-Fi. So the way to look at it is so sending a Wi-Fi packet over 900 megahertz. So the bandwidths are about 10 times lower than Wi-Fi 5. So 802.11h was derived from 802.11ac, but using a lower frequency and bandwidths that are 10 times lower. So roughly you'll be thinking instead of maybe a millisecond on 11ac, you'll be taking about 10 milliseconds with 11ah. So to get packets turned around, and so yeah, Wi-Fi roaming is similar to 11ac, maybe up to 10 times slower. So yeah, instead of milliseconds, it's going to be tens of milliseconds, or if it's tens of milliseconds, now it's going to be hundreds of milliseconds. The good thing though is that because you have 100 times, you get 10 times the range of 11ac, which means you get 100 times the area, is that the number of times you'll have to be roaming is 100 times less than you get with 11ac. If you're driving with your forklift through a warehouse with 11ac, then you have to keep roaming every couple of seconds. Whereas with 11h, you'll never have to roam. Maybe you'll have to roam once you drive with your trolley from the one warehouse to the other warehouse, then you'll move to another access point. But it becomes a problem that's 100 times less of an issue than with normal Wi-Fi.
Yeah, some positive feedback on that one, which is good. I think another question was around any type of frequency hopping, reducing the speed but becoming more resilient, perhaps.
So with Wi-Fi, there's no frequency hopping in the standard. So you pick your bandwidth. So our chips support 1 megahertz, 2 megahertz, 4 megahertz, 8 megahertz bandwidth. But within that 8 megahertz, then you'll use kind of sub channels, and you can then pick whatever channel works best for you. But yeah, in Wi-Fi there is no active frequency hopping. You pick a channel and you stick to that channel. But because it's OFDM based, like there is like a very strong interference handling, and even if certain sub channels completely drop out, you can still have like a reliable, robust connectivity.
And one final question, I think, is in terms of obviously giving the examples in some of the sparse outdoor locations. What would you recommend for modeling, HaLow's range? Would it be some of the existing, kits that you've got, or what would it be that would help to model that?
Yeah. So if you want to test the actual range, then yeah, I'd recommend get one of those HaLow Link 1 units. That one gives you a like 21 dBm output power. So that's what is that? A bit over 100 milliwatts output power, 125 milliwatts output power. And that's what we've used, for example, in Joshua Tree National Park. That same module to give you that long range. Now, if you want to model, if you want to compare how this compares, for example, with 2.4 gigahertz, then you can just look at the maths of it, right? So by going from 2.4 gigahertz to 900 megahertz, you get about a 3.5x advantage in line of sight range. Also, by going from a 20 megahertz bandwidth down to 1 megahertz bandwidth, you get an additional 3 or a little bit over 3x advantage. So multiplying these two together, that's how you end up with more than 10x the range advantage of 2.4 gigahertz Wi-Fi. So if you have an existing device today that gives you, let's say, 400-meter range with a certain 2.4 gigahertz radio using directional antennas, then in that same environment, you'll get 10x the range. And then on top of that, you get a benefit of getting much better penetration through walls and materials. If there's certain deep technical questions, like happy to have people send me an email and we can send some more information about how for example, sub-gigahertz compares to 2.4 gigahertz when it comes to penetrating through glass or brick or plasterboards. And so, yeah.
Absolutely. I think that's most of the questions that we've received. So with that in mind,
yeah. Actually, sorry, one thing I forgot to mention as well, Andrew. So we launched this kind of new MM810A chip at CES. I forgot to mention as well, like we launched a second part in March, which was the MM8102, which is the ultra low power variant of 8108. So 8108 has 26 dBm output power, 400 milliwatts output power. and gives you 43 megabits per second throughput at 8 megahertz bandwidth. We've developed a separate part, which is more focused on the Europe and the EMEA markets, which is much lower power consumption, narrower bandwidth. So focused more on these ultra low power IoT use cases. So that part is called the MM8102. It's got 16 dBm output power, so that's a 40 milliwatts output power, so 10 times lower power, but really focused on those IoT use cases where you need that reliable, robust internet connectivity, but for even much lower power consumption. And so this all meets all of the both chips kind of meet the EU regulatory, but yeah, in the EU, for example, you can only transmit at 16 dBm. So we've made a chip specifically for that EU market.
Fantastic. I think there's one more question that's come through. Let's address that very briefly before we wrap up. And that was if there's any future updates of Wi-Fi HaLow, will any of these come from the Wi-Fi lines? Will it be more from the standards development? What's the kind of future looking like for Wi-Fi HaLow?
Yeah, so it kind of rolls through different standards bodies. So it kind of starts with IEEE, and so we're very active in IEEE, contributing to the standard there. So kind of what you'll expect to see, right, is we'll end up supporting even a higher throughputs and potentially narrower channels, and so you basically get like higher speeds, even longer range. Another step there is integrating MIMO in this technology, so having multiple radios to give you even higher throughput, even longer range. And so that's happening within IEEE, and then within Wi-Fi Alliance, like we work together with other chip vendors to work on that interoperability. And so then it's kind of working with the different players in the ecosystem. And then with the local kind of government bodies, we do work on getting additional spectrum, right? So for example, in China now, where there's trials happening where we're using Wi-Fi HaLow in a certain location in Shanghai to test out Wi-Fi HaLow there and to open up additional spectrum in China for Wi-Fi HaLow.
Yeah, fantastic. I think that the improvements in regulatory environment will be really critical to the future of the technology. I think that's really exciting going forward. One final question, Michael, before we go. I promise I'll let you go at some point today. Expected release date for the USB-C dongle sounds like a good solution for ad hoc networks, which I definitely agree.
Yeah, absolutely. So we'll have this on Mouser in the second half of this year. So the exact release that hasn't been scheduled. So at the moment we're being, to be honest, overwhelmed with requests from some of our early access partners, like tier 1 customers. And so for us, we need to figure out like how we get this into as many millions or tens of millions of devices quickly as possible. And so then we'll open it up to the broader community kind of second half of this year, so that anyone can start using this dongle.
Fantastic. I think that's most of the questions. So, Michael and everyone, I'd like to sincerely thank you all for attending this webinar. We hope you've enjoyed the discussion. It's good to see so many questions. And of course, I'd very much encourage you to download the full white paper, visit the Morse Micro website, and also download the WVA trials report for some more in-depth information on Wi-Fi HaLow and its opportunities going forward. Michael, if you have any final comments you'd like to make before we close up.
Yeah, no, just wanted to thank you for this, Andrew. Like, I think it's great to have like ABI looking into this. Like, I think there's many tens of billions of wireless chips out there, and I think you're right. Like Wi-Fi HaLow is a certain segment, and for us now, it's kind of finding those key segments. I think it's smart metering, it's AI-based applications, it's anything that needs. It's anything that maybe uses LPWAN technologies today, but that one faster throughput. So this is thousands of times faster than LoRa. It gives you 10x the range of Wi-Fi, and so it's kind of that kind of new market segment where this technology will find a lot of value. And so if there's people on the audience here that, for example, looking at a wireless technology that just works, then for their warehouse, school, supermarket, home, residential applications, like this is the technology that's going to give you that reach that Wi-Fi can't give you, and the throughput that LPWAN technologies just don't have.
Yeah, I couldn't agree more, Mike. And I think just one last point for me is that it's not just also about purely on the technology side. It's also about the ease of integration, the kind of scalability, and also the simplified deployment. It's a Wi-Fi technology, it's extension of Wi-Fi. You can easily integrate it to various enterprises, and I think that's really critical going forward. Where if you want to have a scalable, simple, easy to deploy technology, then Wi-Fi HaLow, being an extension of Wi-Fi, just makes a lot of sense. And given the other inherent advantages, I think a lot of people are looking at that, and that's why we're seeing a lot of momentum in the ecosystem. But yeah, that's pretty much all from us today. So again, thanks everyone who has attended. We greatly appreciate you tuning in today. And if you do have any follow-up questions, feel free to reach out via the Morse Micro website or ABI Research websites as well. Hope you will enjoy the rest of your day, and hopefully you can join us again soon for another webinar. But thank you for your time, everyone. Thank you, Michael, for some very interesting conversation and great insight into the future of Morse Micro and Wi-Fi HaLow. And thanks for your time, everyone.
Thank you so much. Bye-bye.
Thanks all. Take care. Bye-bye.